Good morning, everyone. Welcome to Data Physics Coffee Break webinar series. Today we are going to talk about recording using SignalCalc 900. My name is Kalyan Vitta and I'm the product manager for the signal analysis product line at Data Physics. Quick agenda, we'll talk about recording, simple recording, recording with analysis, and later on we'll extend the recording concept to multi-recording. Historically, recording is referred to as tape recording, time history recording, or recording and playback. If your job requires you to travel to the field to collect data, or if your job involves taking measurements on critical equipment and you only have one shot at it, this is the presentation for you. Say you get on a plane, travel several hours, take measurements, and come back to realize that one of the key parameters is set differently in the test, or the project requirements changed on you. Recording will be a valuable tool for you. So what is recording? Recording captures every single time sample so you can recreate the field scenario back in your lab. You can take the recorded data and process it by applying a different window or different averaging technique. And you can do this as many times as you want as you have the original raw time data. In short, recording gives you peace of mind in case you have to recreate and reprocess the data. All right, now let's take a look at the recording process in the 900 software. When you first launch the 900 software, you might see a screen similar to this. A quick recap, the 900 software is divided into 4 sections. Starting with the manage tests, where you can see all the tests at a glance. The run test area, where you will be spending some time in this area while running the test. Once the test is done, when reviewing the results, you will be in the review area. And the last one is system configuration, which shows the systems that are connected to your computer. In my case, I'm connected to a 901 unit, configured with 6 input channels. Let's go back to the manage test area. The manage test area lists the test names, the associated measurement type, the description, if there is a customer associated with that particular test, as well as a test article if one is associated with the test. And the filters in each of the columns helps to narrow down to that particular test. For example, if I want to focus on these 3 areas, then I can just click on the selection that interests me. Similarly, on the test article side, you get the idea. These filters are very useful in terms of narrowing down to the tests that interest you. So to cancel the filter, I can simply click on the X. We also have a global search that would look for any keywords in the whole database, and it would narrow down the tests that you're interested in. Similar to the tests, under the tests radio button, we can also see all the recordings at a glance. The 900 software brings together all the tests and recordings in one place, so you can see all the recordings at one time instead of the recordings being scattered on your computer. Let's go back to the tests and let's start with a simple recording. So click on the new test, and under the analyzer, we have the different measurements and their templates. Let's select recorder as our test type, and let's give it a name, recorder 1. create test. Similar to any test type, autopause spectrum, transfer function, synchronous average, the construction is very similar. We have three tabs, starting with the test tab, which is predominantly for documentation purpose. Under the channels is where you will set your channel table. In my case, I'm going to use the first two channels, and the first two channels are connected to TEDS sensors. I'll select TEDS and click on Read TEDS. So if you don't have TEDS, you can simply set the sensor class to manual and enter the sensitivity for that particular transducer. And let's go to the recorder section. In addition to the test name, I have to give a file name. So let's call it, this is my first recording. Let's call it time record 1. I can select from the drop down menu the sampling frequency that I want to use for this particular test. And from the block size, I can select the number of time samples per frame that I want to see while running the test. So let's go ahead and select 4096. There are some more parameters that we will visit in a bit. Start event, stop event. Let's move on to transfer recording. There are three different selections: leave on hardware, data server, to data server on test end, and to data server on stop. For this first recording, I'm going to leave on hardware. That means once the measurement is done, the data stays on my 901 or the 906 unit. This allows me to start the measurement and disconnect my computer and walk away. Let's go ahead and initialize the test. When I initialize the test, the system provides you some useful information automatically based on the sampling rate selected for this test and number of channels that are active. It provides information such as, if you constantly run this test, in about 6 hours, 35 minutes, and 23 seconds, your hard drive would be full. And in this case, you have 54.3 GB space available for recording. And we are recording at 2.34 megabytes per second. That's the recording rate. That's how fast we are filling up the hard drive. So let's take some data here. So as the test is progressing, you can see the number of frames. These are the 4096 block size frames, the number of seconds, as well as the space it's consuming for this data. So all the information is listed here. Right, once I'm done, I'll click on stop and click on end. To close this test, and as we said before, under the recordings area, that's where my time record that we just recorded is displayed. So if you follow this row, it gives some useful information: the time when it was created, the sampling frequency that we used for this particular test, the size of the file, as well as the length of the time recording. One of the columns is mentioned as location. I want to spend 1 minute here to understand where my data is. So if the location says distributed, that means it is outside the computer. If it is on the computer, it would say data server. So in my case, because we left it on the 901, the data is present on the 901, and the complete data or the full data is available for me to analyze. In cases where you're using multiple 901 units, let's say you go to the field and take a 12-channel test with two 901s, And once you're back in the lab, you only have access to 1901. And in that case, you are only seeing 6 channels of data corresponding to 1901. And instead of full, it would say partial because you only have partial data available for you. But if you connect the second 901, then it would say distributed full. Now, to move this data to the data server, you can manually right click on it and say move to data server. So this is a useful step because once you're done with the data collection in the field and you're back on the plane coming back, and if you want to take a look at the data, if it is on the 901 or 906, you won't have access to it. But if you move it to the data server, once it is on your computer, you can double click on it and you can take a look at the data. We only collected the data in the first 2 channels. Everything else is pretty much noise, micro voltage here. Case 2, if we want to look at the frequency data in addition to the time data, then you have to start with a measurement type such as auto power spectrum transfer function and then add recorder to that measurement. So in this case, let's start with a auto power spectrum and then add recorder to it. In this case, I'm going to select a template. The auto power spectrum is launched from the template. Similar to the previous case, I would select the first 2 channels here, TEDS type, and in my auto power spectrum, all of these is spawned from the test template. Now, if I want to add a recorder to it, click on the plus sign and I can add a recorder to my primary measurement within which is an auto power spectrum. In this case, let me call time record 2. This is the name of the recording. Now, the sampling frequency in this case is set to 5120, which mimics the sampling of the primary test. I can select a different sampling from the drop down here, independent of the primary measurement. In this case, for the transfer recording, instead of leave on hardware, I am going to select to data server on test end. Once the recording is complete, the system will automatically move the data from the 900 unit to the data server. So we don't have to do this operation manually. And I'll also export the format, the data to MATLAB. One more useful feature here under the measurement channels is this button called Sync to Channels Table. So it will automatically synchronize this to my primary channels. If I want to just select the first 2 channels and go back to the recorder because this one is selected, it would only make the channels 1 and 2 active and disable channels 3 and 4 to be in sync with the primary measurement. Let's go ahead and take this measurement. I'll expand my recording. In this case, I have the primary measurement, which is the auto power spectrum 01, the first measurement, and 2 is the recorded measurement. In this case, similar to the previous scenario, now I have 8 days, 5 hours, 41 minutes for this recording, as this one is done with much smaller bandwidth, 2000 Hertz. Click on Start. I can look at my time data here. And just like before, I have all the information for my recording shown here. And I can also move my spectra. I can take my spectral plot and put it here. So I can see my time histories, my frequency data on the same screen. I can take this and move it onto a different monitor if I want. All right. Once I'm satisfied, I'm going to click on stop. So in this case, because we wanted to move the recording to the data server on end, so once I click on end, you will notice that the data from the 900 unit is being moved to the data server. Also, at the same time, we exported the data to MATLAB format. If I close this test and go back to my manage tests, and under recording, I have the time recorder 2, which is associated with this test autopause spectrum plus recorder, and it is already present on the data server. And if I go to my file explorer and go to documents, data physics, recordings, autopause plus recording, and under the run one, I see my time recorder.mat file. As mentioned before, few more things I want to talk about for recording. If I right click and go to the setup for one of the recorders, under the recorder tab, I can start the recording based on a certain amplitude on an input channel. If I see, for example, 4G on channel 4, then I can start the event. Until that time, the system would be monitoring the acceleration on that particular channel, but it would only start the recording at that time. Similarly, stop event, I can set a certain time. Instead of manually stopping the recording, I can say stop the recording after a certain number of seconds or certain number of minutes. When we start the measurement, the system displays a message in terms of the recording speed and the available space and how long it would take for the system to fill in the complete hard drive. So instead of that, you can enable that message under preferences, or if you prefer, the system show only when the hard drive is within a certain percentage. You can set that under the preferences, either 10%, or you can change that number to your liking, or only show if it is within certain number of hours. Also under the preferences, when we export the data, the default selection is under the documents section, data physics, recordings. When you export the data to MATLAB or any other format, that's where it will automatically go. Or you can click on this one and select, you can browse to a different folder on your hard drive. Under the recordings, we talked about automatic export. Now we can also export the data to different formats manually by right clicking on it, and you can export to MATLAB, you can export to ASCII, WAV format, UFFs, just by right clicking on the file in the recording area and exporting to the format needed. So far, we looked at two cases with recording. The simple recording, where we used the test name record1 and we created time recorder 1 recording, and the second one where we used case 2, we used the test APS plus recording while viewing time and frequency domain data, and we created time recorder 2. Now I want to add multiple recordings to the same test. For this test, I'm going to use my 906 unit. So let's go ahead and click on new. And in addition to the autopause spectrum test, APS, I want to add recorder 1, and I also want to add recorder 2. Let's select the FFT analysis as my template, and we will configure recorder 1 as well as recorder 2. The first thing under channels, this is on the right side. If I hover on the edit system, it is selected, the 901 unit is selected as my system to run, but I would uncheck this and I want to select my 906. So the 906 has 36 channels, as you can see here, but I'm going to just use the first 2 channels and use the TEDs, reTEDs. The multi-recorder capability comes here, wherein under after autopause spectrum test, I can add my first recorder. Just like before, I have to give it a file name. Let's call it recorder series A with the sampling rate by default is the same as the sampling rate of my primary measurement. As before, I can pick and choose a different sampling here, much higher sampling, and I would, in this case, the transfer recording, I would select to transfer to data server on stop. And at the same time, I can also export the data to MATLAB. On the right side, I would synchronize to the primary measurement, synchronize to the channels table, as here the first 4 channels would be enabled. For my second recording, I can click on plus and I'll add my recorder here. So recorder number 2, I would just say recorder B series. In this case, I would select even higher, for example, 51,200 as my 51,200 as my sampling rate, and transfer to data server on test end, and I also want to export it to MATLAB. For my second recorder, I'm going to enable circular duration of last 10 seconds. So what circular duration does is, irrespective of the number of hours the test is being run, you will only have data for the last 10 seconds before you click on end. So that's what we will do for recorder 2. Recorder 1, 25,600 sampling rate, and we'll export the data on stop whenever I click on stop. And for the recorder 2, it is much higher, 51,200, but we'll only capture the last 10 seconds, and we would transfer the data to the data server on end and export it to MATLAB at the same time. And let's click on synchronize to channels table as well. And let's go ahead and run this test. All right, I can expand my recorder 1, recorder 2. I don't need to pin this at this time. And if I click on initialize and click on the global start, so you will see that I have 2 recordings in progress, recorder 1 at 25,600 and recorder 2 at 51,200. I can see my time signals, my spectra, my time plus spectra, and recorders are being, the samples are being recorded to the hard drive. I can click on stop on the first recorder, and immediately it would move the data to the data server as well as export the data to MATLAB. I can click on start again, and you can see that once it starts, it's trying to capture the next set of data, and I can click on stop as many times as I want. And every time I click on start and stop, it would move the data to the data server as well as export it to MATLAB format. And one last time, I'll click on start. And this time I will end the complete test. And I'll click on end. So you will notice that my recorder B is also transferring and exporting to MATLAB format. So during this session on the multi-recorder, this is what happened. I clicked on start and stop several times on recorder 1, which created recorder A series. The first one, when I clicked on start and stop, it created record A, and subsequently recorder A 001, 002, 003, it automatically increments the file name. And the second recorder created recorder B and also exported the information to MATLAB. So once I'm done, I can simply close the test and go back into my recordings, and you can see all the recorders, record A 001, 002, 003, as well as the circular recording recorder B right here. With that, we conclude today's session. If you want to reinforce some of the concepts that were touched upon in this session, please visit our YouTube channel, Data Physics YouTube, to learn more in depth on very specific subjects. Thank you for your time. You can always email me, kalyan.vitta@dataphysics.com, or visit us at dataphysics.com. Thank you and have a great day.